EC 111 lecture 13 set 5. We'll be talking about numbers again, and this time we'll be talking about the multiplication of unsigned numbers. Again, unsigned numbers are useful in cases where we're talking about indexing, and we're talking about numbers that don't have a physical meaning of being negative. Every time we do multiplication, if you're doing kind of a desktop multiplication, what happens is that we are taking the values for the numbers, and then you write that like a desktop multiplication algorithm. So if your numbers that you're multiplying in the next one has a 0, and we're all talking about binary numbers here, so if you have a 0, you don't need to bring down that number. But if you have a 1, you should bring it down and shift it. And shifting again meant that we multiplied it by 2. So this is what we are doing, and this is called the array multiplier. So this picture may be showing this more clearly. So we have this adder, which makes the AND of the bits for appropriate bits for this x1, x0 to xn, and kind of takes this value and computes the sum s0 here, and then we kind of do this desktop multiplication. And for the adder, you could use any of the adders we have seen. And usually optimal multipliers are not that easily implementable as adders, because they're bigger circuits, because every cycle of multiplication you're going to use the adders. But to optimize the multiplier, we usually try to combine parts of the adjacent adders, so we kind of save the space. And usually if you're multiplying two numbers that are n bits each, you would need 2 n bits to avoid overflow. And if you're talking about multiplying an n bit number with an m bit number, then the result would be n plus m bits. So if you again don't want to have an overflow, you need to have this product size really thought about in your mind. So as you're writing Verilog, if you're having some multiplication, you need to make sure that the registers or where you're storing those multiplication has enough number of bits. Otherwise, we will get to this problem where we don't know all the values, and this could be problematic. And there are other unsigned operations like division. The division is typically more complicated than multiplication. It needs a larger circuit area and power. We are not going to go through the algorithms for that. If you're interested, these are kind of common subjects you could take a look. But when you have these complicated operations like division, usually the codes you will see for it, or the algorithms you will see for it, are typically performed sequentially. There's of course always room to improve those, but it gets harder when the operations are more complicated. But there's of course this cost performance power trade-off in making more complex circuits. In the next set, we'll be talking about signed integers and how we perform operations on that.